Okay. So yesterday we had seen this Jacobi series. We had seen the Jacobi series here. We see the cosec sine theta, that is J0 is to J2 cos 2 theta to J4 cos 4 theta, a series. Similarly, sin x sin theta 2J1 sin theta plus 2J3 sin 3 theta plus 2J5 sin 5 theta, etc. So this consists of even terms, this consists of odd terms. Okay, so here this is the Jacobi series. From this we express the Bessel function as an integral. What we do is we integrate. First of all, we go for this J0 equal to 1 by pi integral 0 to pi cos x sin theta d theta. Okay, first of all we see this J0x and then we see the general expression. What we do is we integrate 1 between the limits 0 and pi. We integrate 1 between the limits 0 and pi. So we have cos x sin theta integral 0 to pi cos x sin theta d theta equal to this. Okay. So as you integrate the first term, you integrate. So when you apply the limit, you will get pi. And here you have 2J2 this, 2J4 this. And the thing is, as you integrate this, you will be getting 0. Okay. Because when you integrate cos 2 theta, for example, cos 2 theta, you will be getting sin 2 theta, okay, by 2, and you apply the limits 0 and pi, 0 to pi. So sin 2 pi by 2, sin 2 pi by 2 minus sin 0. So you will be getting 0, here also 0 as we integrate. So all these terms will be zeros. So you will be getting only J0 pi, that will be non-zero. So J0 is 1 by pi integral 0 to pi cos x sin theta d theta. So we are expressing J0 as an integral. Okay, so this is just one case. Let's see the general expression. To obtain the general expression, we will be using this result, standard result. See, integral 0 to pi cosine theta d theta, that is pi by 2 delta nm. Okay, delta nm. Okay, integral 0 to pi sin n theta d theta, that is pi by 2 delta nm. Do you know what this is? Delta nm. What is its property? Property of delta nm. This is defined for n equal to m and n not equal to m. Okay, integers. N equal to m and n not equal to m. For n equal to m, what will be its value? I think we have already seen this in the orthogonality relation. Do you see this? Do you see, do you hear what I say? Nobody saying anything. Yes, n equal to m, it is 1. For n not equal to m, 0. Okay. Why others are silent? Always Aparna. Why others remain silent? Okay. So this is the delta of delta n m. Okay, when n equal to m, its value is 1. When n not equal to m, its value is 0. Now what we do is we multiply equation 1 by cosine theta. Okay, multiply equation 1 by cosine theta and integrate between the limits 0 and pi. Okay, so integrate between, so we are multiplying this with the cos n theta. Okay, we are multiplying this with equation 1 with cos n theta. So that is this. So you will get this integral 0 to pi cos x sin theta cos n theta. We are multiplying each term by cos n theta. So you have j0 cos n theta to j2 cos 2 theta. This is cos 2 theta cos n theta to j4 cos 4 theta cos n theta. Because for cos x sin theta, you have even Bessel function values. Okay. So yeah, this you get, and as you integrate, what about the first one? This one. First term, what will be its value? J0 cos n theta. J0 you can take outside. J0. Somebody was saying something? Integral 0 to pi cos n theta, what will be this? What will be its value? Integrate 0. Okay, this will be 0. So this is 0. Okay. Then 2j2 cos 2 theta cos n theta, then you have to integrate. So you have 2j2 integral what cos 2 theta cos n theta d theta. Okay, first this term. Then we have 2j4 integral cos 4 theta cos n theta d theta. Okay, goes on like that. Now what about the value of integral cos 2 theta cos n theta? Integral cos 2 theta cos n theta or cos 4 theta cos n theta. What will be this? What will be this? Integral cos 2 theta cos n theta d theta. What will be its value? We just saw a result. Integral cos 2 theta cosine theta d theta. What will be it? I am not asking about the final result. What will be the expression? See here, integral 0 to pi cosine theta d theta, that is pi by 2 delta nm. Okay, it is pi by 2 delta nm. So what will be this value? Say this will be equal to, nobody responding, this will be equal to, yes, 2j2 pi by 2 pi by 2 pi by 2, say delta 2n delta, yes, this will be 2j4 pi by 2 delta 4n. Okay, then the other terms, remaining terms will be like this: 2j6 pi by 2 delta 6. Yeah. Okay. Now the question is, suppose n is an odd integer. Okay, odd integer. Suppose n is odd integer. We don't know what is it, but we know this much. It is an odd integer. Okay, n is an odd integer. So what will be the value of these integrals? N is an odd integer. What will be the value of integrals? What will be this value? This value, this value. Yes, this will be 0 because all these terms will be 0. Why? Because what we have is even numbers. Okay, what we have is even. One of the index, it's even number, so n has to be an even number for this to be 1. But if n is an odd integer, all these terms will be 0. And suppose n is, so this is n odd integer, this will be 0. N even, suppose n is even. So n is an even number. So what will be this? What will you get? N is an even integer. Okay, we don't know what is its value, but it's even. So what will be its, the value that we get? Okay, what will be the value? Suppose it is n is 4. Okay, suppose n is 4. So then what will be the value you get on the right hand side? You have such terms here. 2, yes, 2j4 pi by 2. Okay, 2j4 pi by 2. Okay. Or we can say j4 pi. Okay. But we don't know whether it is 4 or 6 or not. It's an even number. So what you will get on the right hand side? Yes, jn pi. You will be getting jn pi. Okay. So you will be getting jn pi. Okay. So hope what you understand what I have written here. It is 0. The value of this integral is 0 if n is odd. It is pi jn if n is even. Okay. Pi jn if n is even. N odd is 0. Pi jn if n is even. Okay. So I think it is clear to you. Now what we do is we multiply equation 2 by sine and theta. Okay. I multiply equation. What is equation 2? You just note down equation 2. Equation 2 is the expression for sin x sin theta. Okay, sin x sin theta. And what do? You multiply equation 2 by, equation 2 by sin n theta. We are multiplying this by sin n theta. And integrating between the limits 0 and pi. Integrating between the limits 0 and pi. So, what will be the result that you get? Can you work it out? I think you have understood what I said. You have to multiply sin x sin theta by sin n theta. Okay, multiply it with the sin and theta, and then you have to integrate between the limits 0 and pi. Okay, so can you write the result as we wrote in the case of multiplying the equation by 1 by cos? Okay, I have got this result. 0 if n is odd, pi jn if n is even from the first equation. Okay. Now from the second equation, what do you want to tell us? Second equation. N odd, what do you get? N even, what do you get? Yes. Very good, very good. Others, did you get? Did you get? Okay. So you will get this pi jn if n is odd and 0 if n is even. Okay. Now what we do is we add these two. What? Integral 0 to pi cos x sin theta cos n theta plus integral sin x sin theta sin n theta d theta. Okay, we add them, these two results that we add, and this one is for n odd this will be 0, but this will be pi jn. Okay, and for n even this will be pi jn, but the second one will be 0. Okay, so what we can write, when n is odd, one of it is pi jn, other is 0. When n is even, the other one is pi jn, and the the second one is 0. So you will be getting pi j. Okay. So here we need not write whether n is odd or even. Irrespective of that, this will be equal to pi jn. Okay. So we get jn is equal to 1 by pi integral 0 to pi cosine theta minus x sine theta. Do you know why we are writing this like this? Cosine theta minus x sine theta d theta. See here we have cos x sine theta, cosine theta, sin x sine theta, sin n theta. So that will be something like cos a minus b. Okay, cos a minus b. So we are writing this as cosine theta minus x sine theta d theta. It can be also cos x sine theta minus cosine theta, because cos is an even function. So what do you get? Jn equal to 1 by pi integral 0 to pi cosine theta minus x sine theta d theta. Okay. So this is the integral form of the Bessel function. Okay. So we can write J0. J0 will be 1 by pi integral 0 to pi cosine theta d theta, since this will be 0. Sorry. What will be the J0? This term will be 0. Okay. This term will be 0. So you have cos x sine theta d theta. Okay. And J1 cos theta minus x sine theta, like that. So you can express the Bessel function as an integral. Okay. So that's about the integral form, the Bessel integral. Then we will see. So this you may do as you may add this to the assignment. First one, determine the values of j plus or minus 3 by 2x. Okay. I think you have done the j half x and j minus half x. Okay. I think you have done this. J half x and j minus half x. So you can get j plus 3 by 2 or j minus 3 by 2. We use this recurrence relation. See, we are using this recurrence relation. 2nj and x equal to this. Okay, here if you put n equal to half, you will be getting this. Okay, j3 by 2 of x. Similarly, if you put n equal to minus half here, you can get here you will have minus 3 by 2. Okay, and you can get this. Okay, so do this as assignment. So quite simple. Also you may try this j5 by 2 of x. Okay, j minus 5 by 2 of x. Okay, so do this j plus or minus 3 by 2 of x, and then j plus or minus 5 by 2 of x is assignment. Okay, you just use the recurrence relation. Then from generating function, we have to show this jn of x plus y as equal to jk of x, j and minus k of y. Okay, we have to show that jn of x plus y, that is equal to sigma k equal to minus infinity to plus infinity, jk of x, j and minus k of y. Okay, So you may do this as a assignment. See here what we do, we are using the generating function. We know e raised to x by 2 z minus 1 by 2, that is equal to sigma n equal to minus infinity to plus infinity j n x z raised to n. Okay. Here so for x I am substituting x plus y. Okay. And then we write like this. See, we are writing like this. Here we have this, on the right hand side we have this. Okay. And then we compare the coefficient of z raised to n. Equating the coefficient of z raised to n on both sides, we will get this. Okay. Equating the coefficient of z raised to n on both sides. And also we use this k plus s equal to n. We will be getting the required result. Okay.